Okay, this is part 2 of our 4-3 congruent triangles lesson. We're just cleaning everything up, finishing it up. So I have one proof left to do. So we talked about the third angle theorem when we can prove that if two angles of one triangle are congruent to two angles of another triangle, then we automatically know that third angle is congruent as well. Okay, and that comes into play when we're proving that two triangles are congruent. To prove triangles are congruent, we have to prove that all three angles are congruent and all three sides are congruent, okay? When we do that, to kind of button everything up, the reason that we use is called corresponding parts of congruent triangles are congruent, or in short, Cpctc, okay? So we use Cpctc as the reason why we can say two triangles are congruent if we just prove that all 6 parts of those triangles are congruent. So use as reason, like in a proof, as your reason, as your rule, for proving triangles congruent by proving all 6 parts are congruent. Another time that we can use Cpctc is if we've already stated that all the 2 triangles are congruent. If we start off by saying triangle ABC is congruent to triangle DEF, then after that, any corresponding parts that we say are congruent are because of Cpctc. Because if two triangles, think about it, if this triangle is congruent to this triangle, they don't look congruent, but let's say they are. ABC is congruent to DEF. If I say this entire triangle is congruent to this guy, that means all of their corresponding parts are congruent, right? 1, 2, 3. 1, 2, 3, and then the sides 2, 1, 2, 3, 1, 2, 3. So if two triangles are completely congruent, then I can automatically say angle A is congruent to angle D. Why? Because corresponding parts of triangles that are already congruent are also congruent. Corresponding parts of congruent triangles are congruent. Cpctc. Some kids in previous years use like country people cook tasty chicken or something like that to remember Cpctc, because it is a little tricky, but it's a whole lot shorter to say this than what it stands for. All right, so let's use that in a proof. And I've already kind of drawn out the proof, but here we go. So it gives us a picture of a triangle that looks like it has a line down the middle. And it tells us, first of all, write a 2-column proof. So I've set it up. And it gives us 4 statements, right? It tells us this guy, it tells us this guy, it tells us this guy, and it tells us this guy. Okay, so all of this is in the given. So given all of that, I have to prove that this entire left triangle, triangle ABD, is congruent to this entire right triangle, CBD. My dog is sound asleep on the couch and she just coughed. Okay, so first off, I want to write down the given. AB is congruent to CB. And as I write them down, I'm going to mark up my picture here. So this whole guy is congruent to this whole guy. Fantastic. AD is congruent to CD. AD is congruent to CD. This guy down here is congruent to this guy down here. Fantastic. Then I got an angle. Angle ABD is congruent to angle CBD. ABD is this angle right here, and it's congruent to CBD, this angle right here. And lastly, it tells me that angle ADB, it looks similar, but it's not the same angle, is congruent to CDB. They flip the last 2 letters. So ADB is this guy. It's congruent to CB DB, this guy. That's congruent, right? So all that is given. Okay, so in order for me to prove that this entire triangle is congruent to this entire triangle, I have to prove that all 6 parts, all 3 sides and all 3 angles are congruent. I've already proven, they've already told me that 2 of the sides are congruent to these 2 sides and that these 2 angles are congruent to these 2 angles. So I already know that much. So what else can I say for a fact? Well, we just talked about in this lesson the third angle theorem, right? If I know 2 angles of a triangle are congruent to 2 in another triangle, I know that third angle automatically has to be congruent. 1, 2, 3, 1, 2, 3. So I can say angle C is congruent to angle A. Angle A is congruent to angle C. How can I say that they're congruent? Because of that third angles theorem. Literally tells me that if I already know 2 angles are congruent in 2 triangles, then that third one has to be congruent as well. So now I've said that all 3 angles are congruent to all 3 angles. I said these 2 sides are congruent to these 2 sides. What's the third side, right? Well, it looks like it's this guy BD. It's shared. It's used in this triangle and it's used in this triangle, and it's the same line segment, so it's the same size either way, right? So I'm going to say BD, when it's used in the left triangle, is congruent to or the same size as the BD that's used in the right triangle. Okay, well, what's my reason? What reason do we use when we say the exact same thing is congruent to itself? Do you guys remember? It starts with an R. Reflexive, right? It's the reflexive property of congruence because it's a congruent sign, not equality. It's not a big deal that you write the rest of that. You can just write reflexive because right now nobody's concerned about if it's of equality or congruence. We all kind of assume it's congruence. Okay, so now we've proven that this third side is congruent, whether it's used in this triangle or this triangle, it's congruent. So we've proven all 3 sides are congruent to all 3 angles. So now I have enough to say this entire triangle is congruent to this entire triangle, which is what my proof says. So I'm going to repeat it. Triangle ABD is congruent to triangle CBD. And what's my reason? Whenever I show that all 6 parts of one triangle are congruent to all 6 parts of another, my reason is always Cpctc. Corresponding parts of congruent triangles are congruent. Hopefully that made sense to you a little bit. Let me know if you have questions on that. I won't say we're going to skate over this because it actually is a big part of this lesson, but it's pretty straightforward. So hopefully that all makes sense to you guys.